Welcome to Bio-IT World's Trends from the Trenches podcast, your insider's look at the science, technology, and executive trends driving the life sciences. I'm Allison Proffitt, editor of Bio-IT World. This episode is hosted by Stan Gloss, founder of BioTeam, a life sciences IT consulting company at the intersection of science, data, and technology. Joining Stan today is Dirk Petersen, director of the Supercomputing Center at Oregon State University. Today, they discuss the state and role of high-performance computing in a world focused on AI. Dirk also shares a preview of what he will be discussing in April at the Bio-IT World Conference and Expo. Let's listen in.
Good afternoon, Dirk. It's really great to see you and talk to you. It's been a while since, at least a year since the last Bio-IT World that we saw each other. So I wanted to catch up with you on one of the subjects that we really haven't focused on too much on the podcast is high-performance computing. We talk about AI. We've talked about all kinds of other things, but we really haven't really spent much time going and talking about high-performance computing and the importance of high-performance computing. So I'd like to kind of have a conversation with you today on that. But before we get started, for the people that don't know, this is Dirk Petersen from Oregon, University of Oregon, and an old friend of mine that he's my go-to person when I want to ask questions about HPC. So Dirk, maybe you can just share a little bit about your background so that people know where you're coming from, and then let's get into it.
Awesome. Thank you, Stan, for having me here today. It's a really fun conversation, so I'm looking forward to it. So I should say I'm Oregon State University, and it is of course locally always sensitive because the University of Oregon is the rivaling football team, right? So when you say anything about that is immediate reaction. So you have to always be careful about it. So I'm currently Oregon State University. I spent most of my career at Fred Hutch, a large life sciences cancer research center. Now Cancer Center. And then during the pandemic, I felt that I need to venture out. And then I went to a lot of other places where I saw different perspectives on HPC, but also on like the research computing, right? And so when we talk about HPC, what does that actually mean? Right? That's the first question, right? So does it mean like most people would think that means I am at a very large computing center, Los Alamos, maybe, right? Lawrence Livermore, or like the Texas centers that are there. And you have a giant machine, and you have to go through various hoops to get there in order to get your computing cycle. And you're interacting with potentially graybeards, but there are not many graybeards left anymore, right? There's a very wide range of people who support HPC today, right? But I'm just talking about perception for a moment, right? And but what I'm talking about is more like the enterprise university HPC, right? That's the tier below. That's where all my experience is cited. And that may look slightly different, right? Does that make sense? Do you want to talk about that?
I want to talk about it all. I mean, part of the reason why I wanted to have this conversation is a lot of people think over the years we forget about HPC because it's kind of like the electricity in your house, and until you lose electricity, you kind of you don't even have to think about it. And everybody says HPC is a solved problem. Dirk, is it really a solved problem?
Yes and no. I would say yes and no, right? So, HPC in organizations like ours at the university, I think we have seen like two big trends. The first trend is really as you described, right? HPC should be a solved problem, and you should not have to like go through all sorts of hoops to get there, right? You should just use it like electricity. And then the question is that really happening? Is that what we are seeing? Or is there something else, right? And then I think the main trend there is like the number of people who cannot solve their problem on their laptop is still increasing, right? So whereas like 10, 15, 20 years ago, we had maybe a core community of like diehard geeks, and it was basically a communication, in the hallway or often in person or on like whatever Slack channels. The communication needs to be much wider now, right? It is a service for the people. It is also I would say, a changing role. Research computing used to be a certain department on the fringes, but it has become much more strategic, much more important, right? So especially if you have decided to slash it all and say, let's do away with that research computing, we no longer need it, and let's go to the cloud. Then at some point, people have realized, oh my God, right, we can probably do away with other things, but if we don't have that, now no science is actually happening anymore. There's no area of science where the amount of computing that you need is zero. And that has to really sink in, right?
And going back in time, and when I first entered this marketplace, it was possible to do science on your laptop.
Right.
What you're describing is the long tail of science. And slowly but surely, we're moving out from the geeks that we all know and love, and we were one of them at one point. And now we're actually servicing the longer tail of people who are maybe not as technically savvy, and now they can't do this science. I mean, it's almost like research computing has become a laboratory instrument.
Yes, it has.
Yeah.
It has. And the thing is then how to really make that happen and translate that, right? I mean, I think we see, when I look at like some new architectures, like we see trends where research computing meets like the enterprise. And for example, for me, I've worked in life sciences, also in many like restricted data areas with restricted data. And there is really the question often happening, SSH, right? SSH is the main interface to get into like research computing resources, right? You are installing an SSH client on your computer or on your laptop, or you have already one installed if you're a lucky Mac user, and then you just log into that server and do your things. But that is not necessarily something that is natural to the rest of the enterprise. So there's a real question. Do we actually need that? Isn't that a security risk? We had an attack last week with SSH. We need to disable SSH. We need to enable SSH on request, right? And there's really like two words clashing together as we are moving into this like enterprise space where everybody ought to be using it, right? And it's in the process of happening, or has maybe in some cases already happened, but we see still a lot of barriers making that work, right? Just making it, having things access. If you log in today at your university, you will find that you get a login to Office, to Microsoft Excel, to PowerPoint, right? You can go onto the cloud and you have that service on day one available. It's made available to everybody. But the same thing is still not true, that I don't have a little button in the upper right of my screen that says compute for everybody, right? It is still something that you contact your help desk at your organization, and then the help desk will say, oh, well, let me refer you to so and so, right? And it's still a little bit of a kind of like a separate thing. Like, let me refer you to those people. They are the experts, and they are potentially the ones that are, the geeks and whatnot, right? But we're not at a point where the help desk, maybe like a help desk support person is in the third year of their career or the second year of their career, will just say, okay, yeah, you want computing? Here is a Jupyter notebook, which is my default interface to interface with that big computing machinery. And here's the link, and all you have to do is push this button. And if you need extra help, right, then there is an array of experts for you available, right? And this is where I would want, if I come in and like, I'm always putting myself into the skin of my mom if I want, right? So my mom would want to like do something, and then she says, well, where's the button, right? Where's it? Okay, there's the button, and then I push the button. So what happens when I push the button, right? And we're not quite there with this button yet, right? But we're close. I think we're getting closer and closer. There's technologies like science gateways that have really evolved to be like more mainstream in the last few years. But we're almost at the cusp of it, and that would satisfy me a lot, right? But then there is this whole other dimension of AI, right, where like sophisticated technical requirements come in through AI engineers that are potentially not in line with what HPC is offering, right? And so it's really interesting. In you read this, right? You go onto like the register, and you always wonder, right? I mean, hey, so you see these articles like AI and HPC, right? You read them as if they were like kind of like different things. I mean, look like maybe like 4 years, 3 years, 2 years. You said HPC and AI. I said, that's really strange because for us HPC people, AI is basically just an HPC cluster with some GPUs in it, right?
Right.
That's what for us what it means, right? And of course fast storage and all of that, right? And so I really like befuddled. Why do the and then you ask the question, do the AI people not like us? Maybe is there something like that?
Yeah.
I'm just putting out the question, right? And then you dig deeper. And then I had really the privilege to work with an AI team at one of my places I worked with the last few years. There was a designated AI team, just like very insulated from the rest, but they were focusing purely on AI. And that was a very revealing experience.
Yeah, tell me more about that.
So at first, I would say that the AI engineers, they work with like vast stacks of software. So take the very like simple problem, like an HPC team says, oh, you should not put your like data and stuff in your home directory of where you log in, right? You should not do that. There is a shared drive where you should put your stuff.
Mm-hmm.
And therefore, we are limiting your home directory maybe to like something like 10 gigabytes. Nobody needs 10 gigabytes in their home directory, right? But now the AI person comes in and says, well, let me just install like a bunch of like tiny little pieces of software, such such as PyTorch and even the most common things. And boom, you have consumed 8 gigabytes and you're running out of disk space within the first 2 hours of your interaction with that HPC machine, right? And then if you don't really know the history of any of that, then it strikes you as, who are these people and what are they doing? I can't continue my work.
Right.
So that's the first interaction. Then the other one that I discovered was that basically every AI person traditionally, they are not necessarily always natural Linux or Unix users, right? They often have it on their Mac, but they have various places. And if they interact with Linux, then it is per se on their desktop, which is per se an Ubuntu interaction, right? It's an Ubuntu Linux. Which is almost the same as any other Linux, but there's slight differences, right? But when they log into like an HPC system, then they see slight differences in packages and behaviors and whatnot, and they're really befuddled by that. And they say, "Are you not using Linux?" Right? Because they lack the entire experience of what the HPC people see as the default, which is a Red Hat-like Linux, like CentOS or something like that, right? And that is actually that's where the first kind of like, I wouldn't go as far as calling it a schism, but that's where like people are just like surprised, right? They hit like little obstacles that look like tiny bit of different, and then they are surprised as, oh, what is this, right? I don't find it that easy, right? And then often they come also with like, they don't necessarily know what is schedulers. So a lot of AI people, they work directly on the machine interactively. And then they are venturing into an HPC system where they learn about the existence of login nodes, right? And they have to go through so the entire experience of every like HPC user, right? So it's a constrained environment where you have to request resources, you log into them. It's not hard to do that, but these are the little obstacles that make that already alien, right? And then they type Docker because that's what they have, right? They want to like build a Docker container. And that doesn't exist on an HPC system. On almost no HPC system, you type Docker and anything happens, right? Instead, you will be immediately potentially scolded by an HPC admin who will say, well, we use Singularity, right? And it's better because Docker is not secure, right? And you've had that for the last 10 years, right? And I think that people are adopting to that. But for an AI engineer who has worked a certain way for a long time, that is an alien environment, right?
Are you enjoying the conversation? We'd love to hear from you. Please subscribe to the podcast and give us a rating. It helps other people find and join the conversation. If you've got speaker or topic ideas, we'd love to hear those too. You can send them in a podcast review.
Right. So how do we, Dirk, kind of mesh? And I hate to even use the word mesh because that's another loaded word. But how do we kind of converge the traditional HPC user with the AI user in a world? Because at some point you had mentioned, at the end of the day, people just want compute power. Just
Yeah.
like in our houses, we all want electricity. I just want to take whatever I want to plug into the wall, and I want to plug it in, and I want to turn the switch on, and it works. I don't want to
Yeah.
think about, imagine if your house had both, 110 and 220 volts, and you're trying to deal with adapters all day long, walking around your house going, well, I'd like to plug in the blender in the kitchen, but I can't. I'd have to take that into my office because there's all of these nonsense kinds of things that we have to think about when we can't have this standardization of people should just expect to plug into the wall and get the power that they need to do the things that they want to do with the tool that they want to do. That metaphor actually does carry over. So
Yeah.
how do you in your world of servicing traditional HPC users and now the new AI users, what's that like for you?
What's that like? Yes. Yeah, I can talk a little bit about that, right? So the one to relate to your example with like 220 and 110, I totally agree with you. But maybe more taking things home for all generations of users is that it's just like USB-A and USB-C, right? It's like I have like now a bunch of devices USB-A, and I have USB-C, and then in my car, and it seems always that the likelihood that I miss it is above 50%, right? Although it should be like really
Right.
50%, but it feels like 65% I'm missing it. So, and that's of course really a source of frustration, and I can feel with every person who is with that, right? So I think that's true. So bridging the divide, I find one of the things that was really important was simplification. The AI folks, they want an environment that has good defaults with what they are used to, right? And I think that often they come with experience from, like, they bought an NVIDIA DGX, right? And it worked well, but then the HPC team would say, oh, NVIDIA DGX is really expensive. Let me just get you on Red Hat and put a GPU in it, and then it will do the same thing. And essentially that's correct, but there's a lot of little nuances that are different, right? And so I would really encourage everybody to just familiarize themselves with the DGX operating system and make sure that if you go another route and not use the DGX operating system, which is under the hood is like a flavor of Ubuntu Linux, that you take the functionality that's in there, like the NVIDIA container environment and all the things that NVIDIA builds, and then put that onto your system. NVIDIA is just like, did you know that NVIDIA is a company that has, I believe, like, I think three quarters of them are software and only a quarter is hardware, right? We know NVIDIA from like making GPUs, but what they're actually spending most of their time on is making software to work with these GPUs, right? And
Mhm.
that is really the core lesson. Look at all the things that NVIDIA does and make sure that it works as close as possible on your system, right? Then one workflow that I recall was that almost nobody in HPC is actually editing and writing new containers, new Docker containers, right? They use pre-made containers from somewhere. We have like bio containers or all these like container libraries, and then somebody with wisdom makes this container that's actually a state of the art thing at the time, and then you leverage that by downloading it and running it with Singularity. But a lot of AI people, they need to constantly like build new containers and new environments because they have very complex stacks that have to fit together. So they want to build a container. Almost no HPC environment that is not like advanced, if you want, has the ability to build containers on their node, right? And so I don't want to be too technical, but you need something like called the Linux namespaces sub-UID and sub-GID configured in order to have writable containers on every node in your environment. And if you have that, you make the life of an HPC or of an AI engineer who has a lot of these very, very complicated stacks, you make that much easier, right? And if you have let's say you have a storage system that also has then the lowest latency necessary to do that, then you make them really, really happy, right? I'm not going to talk about any specific vendors here, but a lot of the legacy storage systems that are used in HPC environments, they are not really, they don't have the low latency and they don't have these additional features necessary. So, AI people are somewhat peculiar when they have worked in an environment where that was available before, right? I think those are maybe the main obstacles. But then, Stan, I want to say, break something for the HPC folks now. So when a AI engineer is coming along and says, I need to buy a new system, right? And the HPC engineer then says, oh yeah, we have a custom designed system and we can buy you some GPUs. Then they are totally shocked. Are you kidding me? Is it that cheap? Yes. We are just using an HPC node, right? And we put in a bunch of GPUs, and they work just as if you would buy the most fancy AI machine. Maybe not quite 100%, but close to 85 or 90% with the performance. And then they are really amazed, and they say, I love you guys, right? So in that very moment when you say you offer like real value, and that moment will almost always come that you're able to offer that real value, then they say, wow, you guys are good, right? And then we come to the conclusion, well, AI and HPC, that is not really that different, right? I mean, we do input, compute, and output, right? And we have done that for 30 years, and now we do a tiny nuance with a different input and little bit different compute and output. But essentially, it's the same workflow, right? So from that perspective, yes, there is a really I don't want to go as far as call it born again HPC, but it's something like that, a little bit, right?
Yeah. So I would actually, it's funny you said born again. I was thinking more of a renaissance of,
yeah.
because when we start looking at the news and we seeing companies like Chevron building data centers off of their gas pipelines, because these applications are so power hungry. And we're now seeing more. I just read a report from McKinsey on building the growth and building of data centers across the United States and across the world. That AI is actually driving a new renaissance in scientific computing and high performance computing that this is just the beginning of our conversation of what that is. And, I don't know, do you see it the same way I do?
Yeah, I do. I mean, the change couldn't be starker, right? I mean, go back, maybe 2-3 years. Every large AI or every large like hyperscaler, basically every very big IT company that had a goal for like, we are building like renewable data centers. We want to use less electricity, less and less and less and less. And now it seems that it's all changing, right? We have an enormous demand for resources, for electricity, for more power, and more of that, right? It's just like, it just seems like a no limit, no end. And the growth curve of GPUs is still somewhat, it's not linear. It's still in the neighborhood of exponential, and we're not used to that traditionally, right? Talking about the relevance that you mentioned, right? We are used to like maybe a 20% increase. Oh, we have purchased new CPUs. We're so excited about them. And how much faster are they than the previous generation? 23%, right? But with AI, it's different, right? So there's a new infrastructure coming out every year or every 2 years, and boom, right? You need to replace all your equipment, and you need to just get more power, right? So it is really, it's not the Wild West, I would say, but I could feel a similar feeling like in the times of the gold rush of California, right? You would just say, oh my God, right? There's this unlimited thing, and we need to be part of that, right? I think that reflects some of that feeling there.
Yeah, and I feel a lot of people are getting in their covered wagon and heading west right
That's
now.
right. Yeah.
Anyway,
That's right.
so Dirk, I can't help but mention that you are going to be speaking at Bio-IT World. Do you want to give us a little preview of coming attractions? What's on your mind for sharing at Bio-IT World this year?
Absolutely, yeah. So I have to make a little bit of a selfish plug at Bio-IT, because in my current role, I am director of the new supercomputer that we are building at Oregon State. And so this new supercomputer is part of a more than $200 million complex, and much of that has been donated by a person who wanted to give some money to his alma mater. His name is Jensen Huang, and he makes computer chips somewhere on the west coast of the United States, right? So that's what we can share, and so we are going to build like a $25 million NVIDIA supercomputer, and it is super exciting. There's a bunch of like architectures that are discussed. And we have, I would say, we are probably going to be the first organization that will have the new chip that has not even been discussed, that will come out in 2026. So I'm very excited and look for collaborations with our researchers, with external entities that can potentially make use of this new machine, right? And if I can, we can talk about a little bit more about the new architectures that are coming around in GPUs and why they are useful. But I was just generally saying that I'm super excited about the fact that we will be having this machine, and I can see that people on campus are just like, there's this vibrant thing, that there's something new and there's something big coming. And people have like this glow in their eyes. So I can see this when I speak with folks. I can see this every day. So that's super exciting.
I think there's another follow-on talking about future AI infrastructures and applications. So I think we're going to have we'll have to have another session of this, Dirk, and check in on that sometime soon. I just wanted to say thank you so much for your friendship and support over all the years that we've worked together, and I really appreciate your time today and your interest in what we're talking about. So thanks again, Dirk. I really appreciate it.
Awesome, Stan. It was a lot of fun. Let's do this again.
You bet.
Thank you for listening to Bio-IT World's Trends from the Trenches podcast.